Let's now get another puzzle solved. This puzzle is a well-known one. It is called Sudoku. You probably know it. It is about placing numbers on a 9x9 board under certain constraints. In each row and each column and each 3x3 blocks, the numbers must be distinct. Okay, let's check out the code, which is actually based on an example program on this web page, but I made it I made it easier to understand. First, we have to decide how to represent this 9x9 board, and this is our choice. So we are representing it as a list of lists, which is quite normal programming, since now we have to represent a 2D board. In each such list, we store the numbers in a row. So we have 9 rows. And the numbers, the elements we don't know yet, or so to say, we are looking for their value, are represented by this underscore variable. Okay, in my program, I'm looking for the solutions for 2 such boards, as you can see. Here is the main rule. So I want to solve this kind of board or grid, and this is the predicate I'm going to call from the query. In the parameter, in this grid variable, I'm going to get such a board, and here you can see all the constraints we express on this board. Okay, first of all, we have to check if all the numbers are okay on the board. Then we will check the rows, then the columns, and finally we will check the 3x3 blocks one by one. So let's just check out each of those predicates one by one. So let's check out the numbers okay predicate first. Okay, this is what you can see is a quite normal recursive rule. We check out the first row in the head of this list. Checking here means that that all the numbers in the row must be between 1 and 9, and this is checked by using this built-in predicate, and then we call the predicate in a recursive way for the tail of the list until we hit the base case with this empty list. Okay, we do a very similar job when checking the rows. Let's just check it out. Yeah, so we check out the very first row. What do we have to check about it? Well, all the elements of this row must be different. This can be easily checked by using this built-in predicate, and then I check the rest of the rows. When checking the columns, we could do a very similar implementation, but here you can see a clever solution. Basically, we are reusing the rows okay predicate by first transposing the 2D matrix. This means we rotate it by 90 degrees. And last but not least, we have to do something with the small blocks. For this, we have to introduce names or variables for each for all the rows. Here they are, and then we are going to check them in batches, in batches of 3 rows. First, we check the first 3 rows, then the second 3 rows, and so on. So let's check out how this blocks okay predicate is defined. Well, as you can see here, first of all, we take only the first 3 numbers in each row. Let's just denote them by A, B, C, D, E, F, and G, H, I. And then the rest is easy. we check if each of them contain different numbers, and if they do, then we call the predicate in a recursive way. Okay, it's time to run the query. Okay, you can see a solution for the first table, the first board, and this seems okay. Each elements in each row and column and the 3x3 board are distinct, right? Then let's check out the solution for the second board. Okay, this took a little bit more time because this second board is supposed to be a more difficult one. And here it is. Anyway, solving this second board have not caused any problem for the Prolog interpreter either.